Good night, and tonight I'm here at the Radisson JFK airport on the 11th floor. I'm continuing with the amazing matrix, amazing 5x12 matrix. As previously stated in previous lecture sessions, I am now moving into some more advanced and complex application of the 5x12 matrix. However, intermittently, I will be referring back to my economic output. We have established the validity and facts about the economic output, the SLS, serials like sign output, or DLS, dollar serial like signs output. It's now 23:44 military time. That means we're still at night. Date the 16th of May 2016. And so we continue with our meeting 5x12 matrix. Once again, my name is Dolphy Gilpin. I've been doing physical realization of this thing since about 2005. However, I have started this in my from Schilling's laboratory at City College as my research work. And now I'll be getting into some real electrical electronics application, basic electrical electronics engineering application. And so let's begin. Now, our general matrix will not write down here. It is now abstract. 5x12 matrix in algebraic fashion, in a general fashion. It's now abstract. And specifically, I've drawn this sample from real life situation. It's an economic sample, real life situation. And let's begin now. And so the specific sample here now, which is a substitute of the general sample in algebraic fashion, is, let's say, LF 975 26956 26956 A. Notice the economic configuration. Specifically, this is, say, an $100 bill, an economic configuration. LF 018358 42B LE 123769 62B LF again 01960 435A. And last but not least, LB 86475 8647575 8647575, and that's how. So we have 5 rows, 5 rows and 11 columns, and the 12th column now is F6, F6, F5, rather E5, you know that you have made a mistake because this one is always the mid. So 1, 2, and it's 3 letters is always the mid. 1, 2, 3 letters, so this must be an E. And that is to say that if you were thinking whether it's an F or an E, you would notice an E because it must take the mid of the 3 letters. L, E, and E, Lee, but E is the mid of the Lee. And the last one is LB, B2. B2, and this must be F, I think the 6 again. So we have imposed a specific matrix. The general matrix would be LF, and it will be all in the algebraic form, A, B, C, D, E, F. Okay, we're not going to be going into although I'm here going back into the basic of the PDM processing. And I call it now, this one, the original PDM. You're aware of the DDLI PDM and the TDLI PDM and the QDLI PDM and so forth. The PDLI PDM, the H star DLI PDM and the HDLI PDM and the ODLI PDM and so on. All right, let's start the processing because we're going to be getting into some electronic application here. So we just want to basically just do quickly over the basic part. So we say no, this is LF, A, put it back into that fashion, we put the A over, and we start 018 35842 35842 1 2 3 4 5 6 7 8 1 2 3 7 6 9 6 2 0 1 9 6 0 4 3 5. This look like a 1, so I'll try to make it like a 0. And 8 6 4 7 5 7 3 5. And so the next one will be LF again. This is a real sample, LFB, real life situation, to be differentiated from an imaginary, something that you just think of from your head. This is actually drawn from a banking sample this time around. Call it the economic application. So we continue. This is now 975 2695 6 1 2 3 7 6 9 6 2 01960435 01960435 and 864 757 35. Continue now, we make the LEE operator. LEE operator. Okay, the song means signal smooth operator, LEE operator here. 9752 6956 6956. We have the LEE operator. this is really E5. Usually put this beside it here. E5. This is F6. This is LFB, but F6. LEE 018358 018358 42 019604 019604 35 and 8 64 757 35. And notice we'll get 5 4x4 in the first step of the PDM processing, 5 dual 4x4. So we're working with paired digitals there now, 01835842. So this is 4 columns and 4 rows working in dual pair. Alright, and so we have 3 already. The next one will be LFFSC. And let's do that this now. L F F rather it's LFA rather. LFA. This is LFA, LFB, LEB, LEB. This is LEB, so you could easily make a mistake there. LEB, and the next one is LFA, and this is E5, and LFA. 97526956 01835 842 123769 123769 62 and 864 LFA 75735 75735, and this is an F6 again. Last one of the 5 4x4 dual paired matrix here will be now LBI, LBI. Sample is drawn from real life situation. B2. Now 975 2695 2695 018 358 42 1237 6962 and 019604 35. So we're completing generating the 5 4x4 dual pairs. And so now we continue with the processing, the PDM processing, and we start off now with, say, we choose any one of these 4x4 dual pair from the 5, and we move into the second step. So let's just draw a line here to say that we have completed one step of the processing here. That's just one step. Second step, we have now choose the first one, say, we have now LFA, and we choose the dual pair now, 0, 1, and that goes now. You're going to get some now 16 3x3s dual pair. 16 3x3 dual pair, but we might not generate the whole 16 here because we want to move into some electrical application. LFA, we have now 0, 1, and we get now 37, 69, 62, 96, 04, 35, and 47, 57, 35. And so, and this will be the same F6. LFA 12. 16 of these 3x3 dual paired matrix. Or if it were the case, this would be a 3x6 matrix if it were single digital. But we're not going to go into this basic, but I keep repeating myself on the basic issues here. LFA 12, 83, 58, 42, 83, 58, 42, 9604, 35, 47, 57, 35. LFA 01, 83, 58, 42, 37, 69, 62. And 47, 57, 35. And LFA, so if we could squeeze in one here now, 86, 83, 58, 42, 37, 69, 62, and 9604, 35. All right, so let's move on to LFA 47. You get 01, 58, 42. Oh, 01, 58, 42, 12, 69, 62, and 01, 04, 35. Okay, our pen is getting very dull here now. This is a two-sided pen. Let's see if we could get a brighter side here. Oh, this is a one-sided pen this time around. So we have LFA 96. LFA 96. 01, 58, 42, 1269.62 and 86.57.35. And LFA 37 we have now 0158.42, 0104.35, and 86.57.35. And the last one is will be 83, not here, LFA 83. Let's try to squeeze in another one here. We get 1269.62. Oh 0104.25. And 86.57.35. Notice that in totality these are all unique 4x4 matrix. Sometimes just different by one column or different by one row. Alright, so notice we'll get 16 of this LFA F6. Another 16, 16 and 16, 16, 5, 80 3x3s from this second step of this PDM processing. 18 3x3 dual pair. But we'll not generate the whole 80 of these 3x3 dual pair matrix, because we're going to use some of the format of these now to set up model circuitry, electrical, electronics, engine circuitry. And secondly, we'll be also zeroing some of these numbers to make our calculation easy. You know, I will be doing some full matrix determinant application. The P here is really partial. And notice also we have been dealing with absolute values of the elements in so far in your economic configuration. Absolute values of the element were considered in our electrical electronics application, electrical electronics engineering. We'll be dealing with the real values, in which you will have some negative and positive, and also we'll move into some complex numbers as well. We'll come in, we are doing with inductors, and even power with some vector quantities. So I tell you, we're going to get relatively more complex, moving from absolute value whereby no sign was considered in these elements, whereby real elements and real signs will be considered. Alright, so here's it. We're not going to generate, as I say, the whole 80. 16, 16, 16, 16, 16, 16, 5, 80, 3x3 dual pairs from this second step of the processing. So let's take a break here, and I might return here in a couple of minutes, which will soon land us into the next day, or already we are in the next day. We started off year 23 about 47 military time, which was yesterday, and right now I think it's 00. We are in Tuesday. At this time, 0075 0008 minutes. That is right in the mid-morning, you know. All right, let's take the break and then we come back with our circuitry from here.